Welcome to section 11.17, part 2. This is the 120-second session of the CISSP exam prep series. This part focuses on the workhorses of network filtering, firewalls and proxies. In this session, we'll master how firewalls and proxies filter traffic. We'll answer several questions. What is a firewall really doing? And by what default? How do you filter at the edge? What can a firewall not do on its own? What are the major firewall types, and how do proxies and content filters extend the picture? Why does this matter beyond the exam? Because the firewall is where most people concentrate their trust, and that trust is easy to misplace. Picture a new online store where a single firewall rule, written a little too loosely, quietly exposes an internal admin panel to the entire internet. Firewall failure is usually human error, not a broken box. When you truly understand what each type does and does not see, you write tighter rules and stop treating one appliance as the whole defense. What is a firewall really doing, and by what default? It is filtering traffic between zones of different trust, using a defined set of rules. Those rules, sometimes called access control lists, sort authorized traffic from unauthorized or malicious traffic, and only the approved traffic crosses. The critical mindset is denied by default. Nothing passes unless an explicit rule allows it, and a final catch-all denies everything else. Rules are often evaluated in priority order until the first match wins, so ordering matters. Think of a strict guest list at a private event. If your name is not on it, you simply do not get in, no matter how you ask. How do you filter traffic right at the edge? By blocking, obviously, bogus packets before they get deep. A hardened, exposed system meant to absorb attacks is called a bastion host, named for the fortified guardhouse that once stood in front of a castle gate to take the first blows. At the boundary, ingress and egress filters catch spoofed traffic. For instance, an inbound packet claiming to already be from inside, or an outbound packet pretending to come from outside. You can also drop traffic to or from known bad addresses far upstream before it ever reaches you. Picture a checkpoint on the road well outside the city, turning away suspicious vehicles long before they reach downtown. What can a firewall not do on its own? More than you might hope. A firewall generally cannot stop malware riding inside otherwise allowed traffic, cannot prevent a careless insider from leaking data, cannot catch an attacker already behind it, and cannot protect data once it has crossed. It is also a natural single point of failure, since so much protection concentrates in one spot. The answer is to add capabilities, either through companion tools or through an all-in-one appliance that bundles many functions together. These consolidated boxes go by names like multifunction device, unified threat management, and next-generation firewall. Think of a front door lock, essential but useless against a leak in the roof or a thief already inside. What are the major types of firewalls? There are several, and real deployments often blend them. The simplest just inspects packet headers one at a time. The next understands a specific application or service. Another concerns itself only with setting up sessions between trusted partners. A more capable type tracks the full state and context of a conversation, and the most feature-rich bundles many of these together. A useful way to remember them is by how much context each one considers. From a single isolated packet all the way up to an entire ongoing conversation and its payload. Picture inspectors ranging from one who glances at each envelope to one who follows the whole correspondence to understand it. What does a static packet filtering firewall do? It makes the most basic decision possible. It examines a message header, usually the source and destination addresses and the port numbers, and allows or denies based on that alone. Crucially, it is stateless, judging each packet entirely on its own with no memory of what came before. That makes it fast and simple but blind to context. Think of a bouncer who only checks the address on each envelope and never notices that 100 of them just arrived from the same suspicious sender in a row. What sets an application-level firewall apart? It understands the actual service it is protecting. Operating at the top layer of the model, it filters based on a specific protocol or application, which lets it make far smarter decisions about what is really being requested. A common example guards websites by enforcing strict rules on traffic to and from a web application, blocking web-specific attacks. A cloud-delivered variant extends this idea as a subscription service, filtering between cloud resources and on-premises systems, while layering on extras like inspection of encrypted traffic and data loss prevention. Picture a specialist reviewer who actually reads the contents of a form to judge whether the request makes sense, not just the envelope. What is a circuit-level firewall focused on? The connection itself, not its contents. It works to establish communication sessions between trusted partners, caring about whether a session should be set up rather than what flows through it once it is. It leans on simple rules about addresses and ports, and it too is stateless. A related lightweight tool restricts access to ports and resources based on user or system identity, a basic form of port-based access control. Think of a switchboard operator who decides whether to connect your call based on who is calling whom without ever listening in on the conversation. Why is stateful inspection more powerful? Because it remembers the conversation. Instead of judging packets in isolation, it tracks the state, session, and context of traffic, noting how the current packet relates to earlier ones in the same exchange. That lets it safely allow the expected reply to a valid outbound request by creating a temporary rule that lasts only as long as the conversation. It can spot malicious patterns invisible to single packet checks, and it may even perform deep inspection of a packet's actual payload, not just its header. Picture a guard who recognizes that a returning delivery truck matches the one they waved out an hour ago and lets it back in without fuss. Where do host-based and internal segmentation firewalls fit? They protect from the inside. A host-based firewall installs directly on an individual client or server, defending that one machine from both risky local activity and network-borne threats, and it can range from simple filtering up to the most advanced type. An internal segmentation firewall instead sits between internal segments or divisions, stopping malicious code or harmful traffic from spreading laterally once something is already inside. It is a common building block of fine-grained segmentation. Picture interior fire doors in a building. They will not stop a fire from starting, but they keep it from racing through the whole structure. How do proxy servers extend all this? By standing in the middle between clients and servers. A proxy accepts a client's request, rewrites the source so the client stays hidden, forwards it out, and relays the reply back to the right requester. A forward proxy handles internal users reaching outside services, while a reverse proxy handles outside requests coming into internal services, often sitting at the edge of a screened subnet. If clients are pointed at the proxy without being configured for it, it is transparent, and if clients are explicitly set to use it, it is non-transparent. Along the way, proxies can also cache content and filter sites. Think of a personal assistant who places all your calls under their own name, so the people you contact never see your direct line. What do content and URL filters add? Targeted control over what users can reach. Content filtering inspects the payload of traffic, often matching against a blocked list of unwanted terms or addresses to decide what is allowed through. URL filtering, also called web filtering, blocks access based on all or part of a web address, whether a whole domain, a path, or a file type, and it can pull updated block lists from vendors. A combined web security gateway rolls content and URL filtering together with malware scanning, and sometimes messaging and email filtering too. Picture a librarian who not only bars certain titles, but also reads inside the books to catch banned passages. So let's bring it together. A firewall filters between trust zones on a deny by default stance, with ordered rules and a final catch-all deny. Harden the edge with a bastion host and ingress and egress filters, and remember what a firewall cannot do alone, which is why multifunction appliances exist. The types climb in context, from stateless header checks to application-aware and circuit-level filters, up to stateful inspection with deep packet analysis, plus host-based and internal segmentation firewalls. Proxies mediate and hide clients, and content and URL filters govern what users may reach. In the next part, we turn to endpoint security. The MCQs covering all the topics and concepts from this session are available on rucloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session.